Good afternoon, everyone. Welcome to our webinar with Brand on the topic Functional Testing and Maintenance of Pipettes. I'm Andrea Holzbeck, Supplier Relationship Manager at Avantor. And before we are moving to the session, I will let you know that the webinar will be recorded. The link will be shared with you after the webinar. Please feel free to put your questions anytime in the chat. We will have a Q&A session after the presentation to answer your questions. If you have questions after the webinar, please send them per email at webinar@avantorsciences.com. Our speaker today is Dr. Mariella Neuhäuser. She's working in sales at Brand. And with this, I hand over to Mariella to move forward.
Thank you very much, Andrea, for the warm and insightful introduction and for setting the stage for today's session. Welcome to our webinar with the title Functional Testing and Maintenance of Pipettes, what every pipette user should know. We are delighted to have you join us today as we explore the essential practices for ensuring the accuracy and reliability of one of the most critical tools in the lab, the pipette. Let's have a short overview about the topics we will cover in today's session. We'll start with the point how to identify when maintenance is needed. This includes general inspection and signs to look out for. Then, cleaning and disassembly procedures, how to clean pipettes effectively and perform disassembly safely. We'll go on with leakage testing and methods to check for leaks and correct common causes. Afterwards, we'll have a look on calibration basics and ensuring accuracy through proper calibration methods. And finally, we will illuminate the benefits of regular maintenance with extending the lifespan of your pipettes and ensuring high quality results. By the end of this webinar, you will hopefully have a clear understanding of these processes and practical steps to maintain your pipettes in top condition. When a liquid begins dribbling out of the pipette tip before dispensing even starts, this indicates loose seals. In this video, we check for any air liquid leaks that could affect the accuracy and precision of the pipette's performance. This is particularly important to ensure that the pipettes function properly and delivering the correct volume. For preparation, ensure that the pipette is clean and free of any residue from previous use. Attach an appropriate pipette tip to the pipette. A proper pipette should not release liquid. In this video, you can see a 1 milliliter pipette. It is obvious that there is a leakage. But if you use smaller volumes, as for example a 10 microliter pipette, you will hardly see them dribbling because of the cohesive force of the tips. It is therefore important to service pipettes regularly before they start dribbling, because with this method, only significant leaks can be detected. The first step in maintaining your pipettes is knowing when they need attention. Regular inspection is key. ISO 8655 requires regular calibration of pipettes, but a calibration interval is not specified. Basically, we recommend an inspection every 3 to 12 months. However, the testing interval may be adjusted to your individual requirements. In the case of high frequency of use or the use of aggressive media, it is advisable to check more frequently. The important points are continuous attention. Examine your pipette for visible signs of wear, such as damage to the shaft, stiffness in operation, or improper movement on the pipetting button. To prevent the pipette from becoming inaccurate in the first place, preventive care is essential. Performance issues. Look out for slow aspiration, inconsistent dispensing, or dripping tips. These are clear indicators that maintenance is required. Another important point is the general check. Keep a log of your maintenance intervals. This helps ensure you are proactive rather than reactive when problems arise. Disassemble and clean pipettes regularly and change spare parts if necessary if you are allowed to do that. Also, frequent outside cleaning with isopropanol or soap solution is an important point of maintenance. Regular cleaning is important to avoid contamination. To some point, it also prevents the pipette from dripping. I will show you how to disassemble the pipette step by step in the next slide. The transfer pad S is made out of chemical-resistant materials, and the piston and also the ejector are corrosion-resistant. Therefore, it is no problem to wipe the transfer pad with isopropanol, soap solution, or to clean the parts in an ultrasound bath. The pipette is completely autoclavable. Prior to autoclaving, the volume setting wheel must be set on an available numbered value and unlock the volume change protection. Autoclave the complete pipette without any further disassembling. Afterwards, allow the pipette to completely cool and dry. Maximum safety is achieved through vacuum sterilization. We recommend the use of sterilization bags. If the pipette is autoclaved frequently, the piston and seal should be greased with a supplied silicone grease in order to ensure proper movement. After autoclaving, tighten the connection between the hand grip and the pipette shaft if necessary. The transfer pad is also UV resistant and can remain, for example, in the cell culture hood during UV sterilization and does not need to be taken out every time. Although pipettes are precision instruments, they can be easily disassembled and cleaned. In the next video, I will show you how to disassemble and clean a transfer pad S. So I'm sorry, I think the streaming was not that perfect at the moment, and the video was a little bit slow, but you can also find this video on our YouTube channel. So let's go on with multi-channel pipettes. Also, the disassembling of multi-channel pipettes is very easy. Just pull the pipetting unit downward as far as possible and turn it clockwise. After one revolution, the unit no longer needs to be pulled downward while turning. If the pipetting unit is unscrewed, it must be pulled down again in order to disconnect the magnetic coupling. Take a coin, for example, and rotate both closures of the pipette housing cover by 90% and pull off the pipette housing. Then you can remove the shaft using the installation tool. The seal is located either in the shaft, not in this case, but it's now located on the piston. You can see it here. Remove and inspect the seal and clean it with isopropanol or soap solution. Then rinse with distilled water. If the shaft is damaged or the seal is porous, then cleaning doesn't help and the parts have to be changed. If required, re-grease the piston with a supplied grease. Slide the seal onto the piston with the flat side upwards. Mount and tighten the cleaned or new shaft using the installation tool. Then reassemble the pipetting unit, and the unit must be screwed onto the hand grip in a counterclockwise direction until it clicks in place again. After cleaning, check the instrument for leaks. Also, electronic pipettes from brand can be autoclaved as follows. Unscrew the pipette shaft from the handle and autoclave the complete pipette shaft without any further disassembly. For mechanical pipettes, which can be autoclaved completely, remove personalized labels out of paper before autoclaving. This is not necessary for the delivered labels. After autoclaving, allow the pipette shaft to cool down completely and dry. Screw the pipette shaft of electronic pipettes back into the handle and carry out a reference run. Volume inaccuracies in pipettes can be caused by a variety of factors, with leakage being one of the primary contributors. Over 80% of pipettes sent in for repair have leaks and are outside their volume tolerances, even if they don't drip. Here are some common reasons, including leakage, that can lead to volume inaccuracies in pipettes. If the tip is dripping, the reason might be unsuitable tips or the tip is not seated tightly. We recommend the use of high-quality tips and to press the tip on firmly. If the dispensed volume is too low, there might be dirt on the seal or the seal or cone is damaged. For applications with solvents, for example, we recommend the use of filter tips. Otherwise, the seal might become porous over the time. A further reason for too low volume might be a contaminated or damaged piston, but these parts can be cleaned or replaced easily. Possible reasons for a very slow aspiration might be a clogged shaft. In this case, the shaft should be cleaned. Or in case you use a 2.5 or 10 milliliter pipette with filter, the filter might be contaminated and should be changed. If the dispensed volume is too large, there might be a problem with the handling. Ensure to press the pipetting button to the first stop and not to overstroke point before aspirating. Also consider the temperature of the liquid, which should be dispensed, and the temperature of the pipette itself. The problem of a sluggish piston might be resolved by cleaning and applying a thin layer of grease on the piston. What are the main reasons for leakage? In most cases, leakage arises from damage either to the seals, piston, or tip cones. The PLT unit for air displacement pipettes is a very easy tool to find even the smallest leaks within seconds. A calibration certificate only reflects the results at the time of testing. The time between these calibrations is crucial, since leaks can occur at any time. The PLT unit helps to identify even the smallest leaks in a matter of seconds, making it an essential device for ensuring pipette performance. Studies have shown that over 80% of pipettes sent in for repair actually have leaks. This demonstrates the importance of regular testing to maintain the precision and accuracy of your lab work. Moreover, the PLT unit also allows you to verify the compatibility of pipettes and tips from different manufacturers. This ensures that you are using components that work seamlessly together, minimizing errors and optimizing your results. Whether it's routine maintenance or troubleshooting, the PLT unit is an indispensable tool for labs relying on accurate pipetting in between calibration intervals. I would like to present the performance of a leakage test with a PLT unit into the following short video. The leak rate is a measure of the quantity of material that flows through a leak per time unit. For air displacement pipettes, the PLT unit determines the rate through a differential pressure measurement. If the pipette is mechanically defect-free, clean, and the test is carried out properly with the Brand PLT unit, then the instrument is within the ISO 8655 Part 2 tolerances. The marks in the vertical progress bars in the display represent the resident limit values for the leak rate. With the correlation table in the PLT operating manual, the missing volume can be approximately determined from the leak rate. The level of the progress bar in the display indicates whether the pipette is leak tight and whether it lies within the tolerance limits or leaks. If a pipette fails the test, gravimetric testing is recommended. Immediate maintenance is required if liquid has been aspirated into the pipette shaft, or if the pipette is dripping when aspirating aqueous solutions, if the pipetting button does not move, or if there are any signs of damage. And at functional testing with the PLT unit or calibration shows irregularities. As we have already seen on the previous slide, these are the common spare parts which might cause leakage in air displacement pipettes. They can be replaced by the user easily. But where to find suitable spare parts for your pipettes? There are several convenient options. Start by checking the manual provided by the manufacturer. It typically includes a detailed list of spare parts, along with part numbers, descriptions, and other essential information to help you identify what you need. You can also visit the manufacturer's official website. A lot of manufacturers have dedicated sections for spare parts where you can search by model or part number. Some websites even provide contact information for further assistance. Another easy way to locate spare parts is by scanning the QR code on the instrument itself. This code links directly to the manufacturer website and product page, giving you instant access to the specific parts to your device. Of course, you can also find spare parts on the website from Avantor. Cost, speed, and flexibility, among other things, play a role when deciding whether to calibrate a pipette in-house or externally. The advantage of in-house calibration are flexibility, speed, and, with an appropriate workload, possibly cost savings as well. Cost effectiveness often depends on the number of pipettes. A combination of in-house and external calibration can also be worthwhile, so that the work done internally is validated by an independent external result on a regular basis. If in-house pipette calibration and maintenance is chosen, corresponding equipment and expertise are required. Many pipette manufacturers provide information and support for this. External calibration services are offered by many pipette manufacturers and repair and service centers, which provide independent testing by specialists. External calibration can take longer due to postal routes. But of course, there are costs associated with both external and in-house calibration. Let's now focus on the calibration itself. The standard compliant equipment of an in-house calibration lab includes test equipment that is traceable to national standards, such as a scale, a thermometer, a barometer, a hygrometer, and possibly an appropriate air conditioning system. For the calibration of small volume pipettes, special accessories that are used for evaporation protection should also be included. It is also helpful to have a calibration software that can automatically calculate and evaluate the existing measured values of a pipette and document the instrument-specific test results. So let's focus now on the gravimetric testing itself. The procedure for calibration in accordance with ISO 8655 is generally always the same. If the ambient conditions required from the ISO are present, the pipette must be placed in the calibration lab 2 hours before the test, so that the temperature of the pipette, ambient air, and water are the same. The pipette is tested at nominal volume, 50% of nominal volume, and 10% of nominal volume, or the lowest partial volume. Once the pipette is set to the target volume, 10 pipetting operations are dispensed into a vessel on the balance, in compliance with specific handling instructions and the results recorded. By multiplying the mean value of these 10 weight measurements by the applicable set factor, the actual pipetted volume is determined. Evaluating the deviation between the actual volume and the target volume ultimately shows whether the pipette is within the defined tolerances or not. Additional information and details about the test sequence and the calculation can be found in the test instructions of the manufacturers. If the leak test, which is performed in connection with the calibration, does not reveal any errors, and technique handling and ambient conditions can be excluded as the cause of error, the pipette must be adjusted. In most systems on the market, an adjustment involves correcting the piston stroke length. The disadvantage of this procedure is that a careful approach must be taken, and as a result, readjustment may be required in a further step. In addition, a tool is usually required. Adjustment on transfer pad S and transfer pad electronic pipettes is quite simple with the help of easy calibration technology. Change the display to the actual measured volume on the decoupled pipette without tools and within a few seconds. This quick and easy procedure is shown in Figure 3. Because the easy calibration function is a safe and field-tested method, it can be assumed that no significant deviation will occur after the adjustment. Nevertheless, the volume should always be checked again after doing so. Intelligent research management is very important nowadays. It is the certified part of many company guidelines. Due to the use of high-quality materials, Brandt pipettes can be used for many years. Actual service life depends on factors such as media, handling, and maintenance. Under standardized test conditions, a transfer pad S can perform 500,000 strokes and 200,000 tip ejections without compromising accuracy or function. It's a true long runner in the lab. Regular cleaning and maintenance can significantly extend its life. Our environmental management system has been certified since 1998. Therefore, we are committed to continuously optimizing our environmental performance. In addition, our energy management system has also been certified. This makes us one of the pioneers in our industry for the intelligent use of energy. We focus on saving as many resources as possible in production by designing our products to be long-lasting and maintenance-friendly. So that's it from my side. Thank you very much for your attention. Are there any questions?
Yes, we have some questions. One question is about the Z factor. You mentioned the Z factor in your presentation. What is this factor?
Yeah, thank you for the question. The Z factor depends on air pressure and temperature. You can find the Z factor values in the for different temperatures in the SOP on our website, or maybe you can find it also on the internet, and it's all described in the ISO 8655 Part 2.
Thank you. A second question is about the PLT unit and steppers. Can the PLT unit also be used to check steppers?
That's also a good question. No, the PLT unit cannot be used to check steppers, because steppers are direct replacement pipettes, and the PLT unit is designed only for air displacement pipettes. But it doesn't matter which manufacturer. It works for all air displacement pipettes, but not for direct replacement pipettes. Are there more questions?
Yes, there is one more question. Must the pipette be calibrated after disassembling?
Oh yeah, that's very difficult. This of course depends. If you do anything and on a volume determining part of the pipette, for example on the piston, then of course yes, we recommend to calibrate the pipette afterwards. But if you only check the nose cone without greasing the piston, for example, then it won't be necessary for transfer pads. Good. I can see we run out of time, but yes, we will answer all your questions later on. Andrea, do you have any comments on that?
Yeah, thank you very much, Mariella, for this great presentation. Thank you all for listening. I hope you had an interesting session. You will receive an email with a link to the recording, so you and your colleagues can listen again whenever you want. And you will also find the recording on vwr.com in our event webinar corner. Also, a survey will come up to you after the webinar. Please share your thoughts here to make things better. And last but not least, every attendee will get a certificate of attendance afterwards. So I wish you all a very nice rest of the day. And that's from my side. If there are no more comments, I say thank you to all.
Thank you very much. Bye bye.
Bye.